Good morning, children. Class 8, subject chemistry, chapter 5, language of chemistry. So, in this chapter, today we are going to learn information gathered from a chemical equation, limitations of chemical equations, and more informative equation. So, what are the informations we can able to gather from a chemical equation? First one, it tells us the reactants and the products of the chemical reaction. So by looking at a chemical equation, we can able to know which are the reactants and which are the products. So look at this example. Magnesium reacts with oxygen, produces magnesium oxide. So always the reactant should be written on the left hand side of the equation and product should be written on the right hand side of the equation. So it is easy for us to identify the reactants and products. So here in this equation, magnesium and oxygen are the reactants and magnesium oxide is the product. Okay, so the first information given by a chemical equation is we can able to identify the reactants and products of a chemical reaction, and it also tells us the symbols of elements and the formulae of compounds. So look at the first example. Iron reacts with sulfur, produces iron sulfide. So the symbol of iron is Fe, the symbol of sulfur is S, and the formula of iron sulfide is FeS. So likewise, carbon reacts with oxygen, produces carbon dioxide. The symbol of carbon is C, and oxygen O2, carbon dioxide CO2. So by looking at the equation, we can able to know the symbol of elements and the formula of compounds. And it also tells us the number of atoms and molecules in the reactants and products of a chemical reactions. So how many number of atoms or molecules involved in a chemical reaction will be known with the help of the equation. So the first equation, iron reacts with sulfur, produces iron sulfide. So one atom of iron combines with one atom of sulfur and produces one molecule of iron sulfide. And in the second example, one molecule of nitrogen reacts with 3 molecules of hydrogen and produces 2 molecules of ammonia. So by looking at the equation, we can able to know the number of atoms and molecules involved in a chemical reaction. And it also helps us to calculate the mass of reactants and products. So let me calculate the mass of reactants and products of this equation. So one molecule of nitrogen reacts with 3 molecules of hydrogen and produces 2 molecules of ammonia. So one molecule of nitrogen contains 2 nitrogen atoms and one molecule of hydrogen contains 2 hydrogen atoms. So let me calculate the mass of reactants. So 2 nitrogen atoms, the atomic mass of nitrogen is 14. Therefore 2 into 14, 28. And now we'll calculate the total number of hydrogen atoms. So 3 molecules of hydrogen. So one molecule contains 2 hydrogen atoms. Therefore 3 into 2, 6 hydrogen atoms are there. The atomic mass of hydrogen is 1. Therefore 6 into 1, 6. So totally the mass of reactant is 34 grams. So likewise we'll calculate for the product side. So 2 molecules of ammonia. So it contains 2 nitrogen atom and 1 molecule of ammonia contains 3 hydrogen atom. Therefore 2 molecules of ammonia contains 2 into 3, 6 nitrogen atoms. Okay. Therefore 2 into 14, 28 and 60 to 1, 6. Therefore the mass of product is 34 grams. So we can able to calculate the mass of reactants and products of the reaction. And the mass of reactants is equal to the mass of products in a balanced equation. So already we have calculated the mass of reactants and products. So now we will calculate the number of atoms. The number of atoms in LHS side is always equal to number of atoms in OHS side. Okay, so nitrogen plus hydrogen both reacts and produces ammonia. So now we will calculate the number of atoms in the LHS side. So 2 nitrogen atoms and 3 hydrogen molecules. That means one hydrogen molecule contains 2 hydrogen atoms. Therefore 3 hydrogen molecule, 2 plus 2 plus 2. Therefore 6 hydrogen atoms are there. So LHS side 2 nitrogen atoms and 6 hydrogen atoms are there. So now we will calculate on the RHS side. 2 ammonia molecules. Therefore 2 NH3. So 2 nitrogen atom and 3 plus 3, 6 hydrogen atoms. So the number of atoms in both the sides are equal. Therefore, the mass of reactant is equal to the mass of products in a balanced equations. And a chemical equation also tells us what happens in a chemical reaction. For example, look at the equation. Zinc plus HCl gives ZnCl2 plus H2. So by looking at the equation, we can able to tell what happens in this reaction. That is, zinc reacts with hydrochloric acid to give zinc chloride and a hydrogen. So these are the informations gained from a chemical equation. Okay, children. And now we are going to learn the limitations of chemical equations. So these are some of the informations that are not provided by a chemical equation. Number one, the physical states of the reactants and products is not provided. Number two, the concentration of the reactants of the reaction is not given. The heat change during the reaction is also not indicated, and the conditions necessary for the reaction is also not informed, and the nature of the reaction is not provided. So these are the informations that are not given by a chemical equation. So let us add these informations in order to make the chemical equation more informative. So the first one, the physical state of the reactants. So whether the reactants and products are solid, liquid or gases, whether it is an aqueous solution or it is a non-aqueous solution. So it should be indicated. So look at this example. Sodium reacts with water, produces sodium hydroxide and carbon dioxide. So here sodium is a solid. So therefore we need to indicate sodium is a solid. We need to indicate with the help of a small s within the bracket. And water is a liquid. So small l is used and it should be used within the bracket. And sodium hydroxide is an aqueous solution. So what is an aqueous solution? The substance will be dissolved in water. So if it is dissolved in water, it is said to be an aqueous solution. If it is dissolved in some other substances, some other solvent, then those are called as non-aqueous solution. So if it is an aqueous solution, it should be indicated within the bracket. AQ should be indicated within the bracket. And carbon dioxide is a gas, so small g is indicated within the bracket. So for solid, small s is used. For liquid, small l is used. For gaseous state, g, small g is used. If it is an aqueous solution, we need to use AQ. So everything should be enclosed within a bracket. Okay, so now we have provided the informations. And the concentration of the reactants should be informed. So how we can provide the information? If it is a concentrated acid, we need to add CONC, all small letters with a dot. It should be placed in front of the formula of the compound. Suppose if dilute acid is used, means we need to place DIL dot. All small letters we want to use, DIL dot should be placed in front of the formula of the compound. What is a concentrated acid? What is a dilute acid? So especially in chemistry, concentrated means, for example, if you have taken 100 ml of water and we have taken 2 glasses, both contains 100 ml of water, and in one glass we have added more amount of solute, and in another glass we have added very lesser amount of solute. So the lesser amount of solute added is a dilute solution, and more amount of solute added is a concentrated solution. So concentrated solution means solute will be more and solvent will be the same. And dilute means solute will be in lesser amount. Okay, so concentrated means we need to add CONC dot in front of the compound, and dilute means we need to add DIL dot in front of the formula of the compound. Okay, so the concentration of the reactant should be indicated, and the heat changes during the reaction will also be mentioned. So a chemical reaction in which heat is given out is called an exothermic reaction. So heat is given out, therefore it is indicated by plus heat, and it should be written in the product side, because heat is given out, therefore it should be written on the product side. So plus heat should be written on the product side. And if heat is absorbed during a chemical reaction, it is an endothermic reaction. Here we want to add plus heat in the reactant side, because heat is absorbed by the reactants, therefore it should be written on the reactant side, plus heat. Okay, so heat changes is indicated with the help of the symbol plus heat. If it is an exothermic reaction, it should be noted on the product side. If it is an endothermic reaction, it should be noted on the reactant side. And the conditions of the reactions will be indicated above and below the arrow mark of the chemical equation. So some reaction takes place only at high temperatures, and some reaction will take place at lower temperatures, and some reactions are initiated or controlled by a catalyst. So all should be mentioned above and below of the arrow mark. So what is a catalyst? So catalyst is also a chemical substance that increases or decreases the speed of the reaction. Okay, so if the reaction goes fast, it just slow down the reaction. If it is very slow, it just fasten up the reaction. It controls the speed of the reaction. Otherwise, it initiates the reaction. So we can take this example. Potassium chloride decomposes into potassium chloride and oxygen in the presence of magnesium dioxide, which acts as a catalyst in this reaction. So magnesium dioxide do not involve in the chemical reaction. It just acts as a catalyst. It initiates the reaction or it controls the reaction. So catalyst. So the conditions should be mentioned above and below the arrow mark in a chemical equation. And the nature of the reaction should be mentioned. So most of the chemical reactions proceed in both the directions. So both forward and backward directions. So those reactions are called as reversible reactions. That is, the reaction can be reversed. That is, the products can be again converted into reactants. Okay. So look at the example. Nitrogen reacts with hydrogen, produces ammonia. Okay. So forward reaction, what happens? Nitrogen and hydrogen combines, produces ammonia. So nitrogen and hydrogen are reactants, ammonia is the product. And what happens after some time? The ammonia started converted into hydrogen and nitrogen. Now the ammonia becomes the reactant and the products are nitrogen and hydrogen. So this is the reverse reaction. Reverse reaction will take place. So both the forward and backward reaction will take place simultaneously. So in most of the chemical reactions are reversible reactions only. So reversible reactions are indicated with the help of a off-headed arrow mark in both the directions we want to use. Forward direction one arrow mark and backward direction another arrow mark will be used. Okay, okay. So the nature of the reactions will also be indicated with the help of this equation. Thank you, children.